So today we are going to talk about data flow diagrams.
Now, what are data flow diagrams?
Data flow diagrams, obviously as the name suggests, they tell you how your data is going to travel within your app. So basically if you are trying to create a software, so the most important part of your software, even more important than your source code, is your data, because users are going to put a lot of data in your software. So you need to understand how your data will travel from one module to another. Usually we say ER diagrams are created for database schema, maybe class diagrams for your objects. But when you talk about DFDs, they are both. Like they also help you in visualizing the data movement, the requirement of data, everything, and they also help you in visualizing what will be your major modules. So of course, so data plus functionality both can be planned, both can be designed using data flow diagrams. So they are important. Now,
Okay, so what are the technical terms that we need to know to get into DFDs?
so you mean components of DFDs?
Yeah.
Right. So the major components of DFDs are, first we'll talk about something called as external entity. I'll say then you have processes, then you have data flows, and then you have data stores. So these are the four major components that you will find in any data flow diagram whenever you see one or you create one. So let's talk about general symbols. Usually entities are denoted using rectangles. Processes are denoted using bubbles, or you could say circles. Data flows are data flows, and data stores are drawn like this, something like, and then all of these are labeled like external entity, user, process like some kind of calculation. Then you have data flow, user info. Then you have data store, registry, information, something like that. So everything is labeled correctly. But these are the usual symbols for your external entity, process, data flows, and data stores. Now the question is, what is an external entity? This entity differs quite significantly from the entity in your ER diagram. So external entity, so it could be a person like me, a user of Facebook. It could be a hardware, or it could be another system or program which either provides data to your software or which consumes data from your software. So anything, any object like person, hardware, or another software who either consume data of your software or who provide data for your software are qualified as external entities for that particular software that you are building.
Now, what do you mean by persons? I mean the admin, the users.
No, yeah, both basically. See, if we consider Facebook as a system, the software for drawing the DFD, then we could say the users are external entities because they are going to provide data, they are going to consume data. Yet they are not part of the system. Users are nowhere when you build the software. They are only going to give you data and take data. So they are external to the system, but they are there. So they are external entities.
And how exactly are hardware going to be in this thing?
Yeah. For example, your sensors. For example, there is a security software needs to be created for a shopping mall, right? Which analyzes the patterns of people. How do they, if there are any thieves or something like that. So for that software, the data comes from your CCTV cameras, right? Or sometimes the temperature is sensed by, or even your smartphones, right? For your smartphone, there are sensors like accelerometer, gyroscope, some compass. So in that case, they provide data to the software. So that way they become your external entity.
And how?
Yes.
And how do softwares become a part of this?
Yeah, as I said, external, another software could be an external entity for your system. The best example would be nowadays almost everyone uses this Facebook share, Facebook authentication in their web application or mobile application. So basically what you are doing is you are taking the data from Facebook for users authentication. You are using Facebook's users username, picture, email address, and then sometimes through that application people can share on Facebook, post on Facebook, comment on Facebook. So you are also posting data on Facebook through your app. So though Facebook is not part of your application internally, but it is acting as an external entity for your app because it is providing you data and it is taking data from your app, right? So we both covered all the possibilities. There are a few basic rules about external entities. First of all, they should be named. There cannot be a data flow between two entities directly. We'll see that again and again, this rule, but these are some basic rules. Then we go to processes. Now what is a process? A process is something, some code or something which works on data and transforms that data into something else. So basically it's simply like it takes data and it converts it into information. That's what we do as a software people. We take data, we find out something meaningful from it and store it somewhere. So process is something which transforms the data. There are some rules about processes. They are shown using bubble. Again, they must be properly labeled and they should not be repeated in a diagram. Like for example, you cannot repeat a particular process twice in a DFD. Then you have data flows. So this is the most important thing perhaps in your DFD is how you denote the data flow. So data flows are usually shown like this, an arrow. Data flows are not bidirectional. That's a very basic rule. You cannot draw a data flow like this, right?
So are there supposed to be two different arrows for that?
Yes. See, if this is the arrow for input, then there has to be separate arrow for output, right? So we'll discuss that. But you cannot have data flow like this, bidirectional. That's not allowed. And data flows should be labeled very properly, every data flow. And labels should be meaningful. They should not be meaningless like data. They should not be vague. So there are data flows. Then there are data stores. Data stores are always internal to the system. Imagine them as like your database tables or even entire databases. Or they don't have to be only databases. They could be files. Anything where you store the data apart from process, right? Process store data in variables, arrays, in memory, right? But for persistent storage, you use some kind of mechanism. Some people might use a actual register, paper register, like a muster, right? That also could be a data store. Your database table could be a data store. Your files, some people do not use database, they store data in files. Files could also be data store. So those are all called as data stores. Data stores are depicted like this between two, what you could say, parallel lines. You have to draw. A few rules regarding data stores. Again, just like external entities, there cannot be a data flow between two data stores directly. Like you cannot have something like this. Two data, something like ABCD, and you cannot have data flow like this. Not allowed. There has to be some process which moves data from one data store to another. Similarly, as I said earlier, there cannot be a data flow between two entities directly. There has to be some process in between which moves the data from one external entity to another. And okay, general rules. So I'll just summarize them one by one. No internal logic. That means data flow diagram is not a flow chart. You can't show if, else, loops, and then programming constructs in a data flow diagram. Data flow diagram, even though they consider the functionality of your application, it is at very abstract level. You will only show bubbles for your modules, nothing more than that. Then second thing is, to keep the data flow diagram uncluttered, you can repeat the external entities and data stores. Remember what I said, you cannot repeat a process. So if you do not repeat anything, then it becomes kind of messy, right? Everything just flows by everything. So you can actually use some technique for data flows. Like for example, these are two entities. Okay, I'll draw it here. I'll just remove it then. Two entities and this is one process. So if this is the input flow, this is the input flow, and both flows are actually the same, like some A and A, right? So instead of drawing two flows, you use a join, like you can show them here and then join them before you give them to process, like A. This is allowed, this is join for data flows. And if there are two outputs like B and B which are going away from the process, you can again draw one and then separate them to their respective destination. One goes inside the data store, one goes consumed by your entity. So in this case, this is called as fork. This is your join incoming, right? And this is outgoing, so that is fork. Very important rule, one more rule is, you cannot have miracles or black holes. So there cannot be any miracles or black holes. Miracle, what is miracle? Miracle is a process which only gives output data flows. So there are only output data flows coming out of this process. So basically this process doesn't have any input data flow but all output data flow. That means information is just coming out of this process without any input, which is simply not possible. You cannot go against Newton's third law of motion. Energy can neither be created nor be destroyed. It just gets converted from one form to another. So if there is no input, there cannot be output. Similarly, the opposite end of the spectrum is black hole. Black hole is a process which only has input data flows. So there is only input and there is no output. Like the black carbon that they put in the face wash creams. They say that black carbon absorbs everything. But unfortunately, there are no black carbons available or permitted in DFDs. You cannot have a process which only has the input data flows, no output. Similar rules apply to data stores. So data stores cannot be sink or sources. So you cannot have data store which is a sink. Sink means that data store only has input data flows into it. So there is a table, imagine there is a database table where you only put the data. You never read the data. Is it really possible? I mean, I want to ask you, yes. Is it possible that you have a table where you only store the data? You do not read the data at all.
Then there is no use of storing the data.
Yeah, then there is no purpose of storing the data. So you cannot have a data store which has only input flows and no output flows. Similarly, data store cannot be source. That means you cannot have a data store which only people read from. There are only output flows. There is no data going in. People are only reading. Magic. Where is data coming from? I don't know. No, nothing. Beware of this. When you go to level 2, when you go to level 2 diagrams, we'll see what level 2 diagrams are. In level 2, you might draw a data store which appears like a source. But it's not actually. I'll demonstrate how it is. Right? But in level 1, you do not show data stores in level 0. No question of that. In level 1 diagrams, your data stores cannot be sink or sources. Right? You have to label and you have to label it meaningfully. And again, I repeat that no direct data flow between two entities or two data stores. Direct data flow between two processes? Yes, totally possible. Totally possible. Like your two web pages which send each other data through query string, appending it to URL, right? Or you post the data to the server, so that is totally possible. But not between two tables. You cannot have a situation where one table copies data from another table automatically without any code. Possible? No. Not possible. Similarly, like two users of Facebook exchanging data without any process. Like, I don't know. So that's not possible. So these are the general rules for creating data flow diagrams. Beware of them. I'll repeat them when we draw the diagram. Yes.
So what is the context level diagram exactly?
Yes. So basically when you draw DFDs, you draw level 0 DFD, then you draw level 1 DFD, and then you draw level 2 DFD. So you draw 3 DFDs in total for any software system. You always begin with level 0, which is also fondly called as context level diagram. Then you draw level 1 diagram and then you draw level 2 diagram. For any software system, there is only one possible context diagram. There is only one possible level 1 diagram, and there are more or many possible level 2 diagrams, right? So this is a general structure. Now let's see what context level diagram is. Level 0 diagram is a, I would say, bird's eye view of your software. Like for example, when suppose you are sitting in a helicopter and flying over a software company, right? You work in a software company and now you are flying in a helicopter just above it. And you want to show it to your dad, who is also accompanying you in your helicopter. You are very rich. So what do you see of that software company? What do you see?
Just the roof.
Just the roof, right? You could say, okay, that is my software company, right? Nothing else can be told. You cannot say, Dad, okay, there is my cabin. No, you cannot do that. You can say, okay, that is my software company.
Also, we could be able to see a rough structure of the company.
No, not rough structure, but you could see employees coming and leaving. You could say, okay, wait, that is the company bus that's coming in. That's a security bus coming in. That's a courier bus coming in. So you could see the external people that work in that system, that company. You could see them. And you could see company as one big building, right? So context level diagram is exactly that. Your entire software system is one big process, right? And then you can identify all the external entities that are there which work for your software system. All the external entities are listed in the context diagram. As I said, external entities could be a hardware, could be a person, or could be another software which either provides or
Takes data.
consumes information from your software, right? The arrows are shown. See, if there is a data input from the entity, it is shown like this. If it reads the data, then it is shown like this. Remember, there are no bidirectional arrows. Always. So if this entity only gives the input, great. If this entity only reads the data, great. If this gives both, then great. Again, one thing, you have to label this, and you have to label this. Label everything. You have to label everything in a meaningful way. When we draw a DFD, very soon, we'll go through this entire thing. So few rules regarding context level diagram. There could be only one process which represents your entire software. All the external entities are identified at the context level. You cannot add a new external entity after context level diagram. No new external entity can come in level 1 diagram. Only those which you identified in context diagram can be shown in the level 1 diagram or level 2 diagram. Then data stores can never be present in your context level diagram. You cannot show a data store like this in the context level diagram. You may want to ask why?
Yeah, why is it so?
Okay. So as I said earlier, data stores are internal to the system. For example, there's a muster where employees sign their attendance. Will you be able to see that muster from the helicopter?
No.
Or maybe there's a server room, Facebook's server, where it stores all the data from all the members of Facebook. Will it be visible from helicopter?
No.
That is internal to the system. So that is not, data stores are not shown. But there could be possible exceptions. For example, do you know this IRCTC website?
Yeah.
What does it do?
It does Indian bookings for railways.
Railways. Ticket booking for railways in India, right? IRCTC. But prior to IRCTC, do you know what was the way to
It
do
was
the
a
tickets?
conventional way. You have to go to the office, book the ticket.
Yeah, you have to go to the station and book your ticket. But even that station guy used to have a computer, the MS-DOS kind of computer, and they used to enter the details and then give us a ticket. So there was some database. There was some central database, right? Even though IRCTC is there, the old school booking is still on.
Yeah.
That means there's also those traditional computers where they book the tickets for you on the station, and then there is this IRCTC website where people book it. See, this is my IRCTC system which I am designing. Then there is this Railway Central Database RCD, which is already there, up and working, which is going to provide me data and I'm going to store data in it. So, isn't this external entity for IRCTC system?
No, because it has to be in the app.
No,
I mean-
it's already there. App is yet to be born. I'm just designing IRCTC. This is not IRCTC's database, mind you. It is used by the current system, which is computer at every station. This is not, I'm not designing it. It's already there. Getting it?
Yeah.
And still I need it because that's the way it is. So, isn't it external entity for me?
At
But it's
least.
a database.
At
So I have to
least.
show it like this. So the thing is, in context level diagram, even if there is a data store, that data store is shown as
External entity.
entity. Exactly. Now we go to level 1 diagram. So level 1 diagram is what you could say is a bigger view, better view of the system, right? So it's basically you land from the your helicopter lands, you get down from the helicopter with your dad, and now you are at the gate of your company, and there is a security guard over there, right? Your dad is talking to that security guard while you are on phone or something. So what that security guard will be able to tell your dad? So this is a company building, this is the gate. Your dad is talking to him. What will be he will be able to tell?
Some overview about the departments in the whole
Like
company.
he would be able to say, okay, HR is on 3rd floor, the admins are on 2nd floor, the software people sit on 5th floor, something like that. So he would be able to describe the entire system, but none of them in detail. So if your dad were to ask, okay, in software section, where does my boy sit? Where does my boy sits? So he'll say, I don't know. I just know there are software section in that floor. That's it. So level 1 diagram is exactly that. It describes the entire system but at a very abstract level. That is, if this was your context level diagram, let's say 3 external entities and 1 system, then your level 1 diagram is this you decompose. So you consider this as one system. Now you show all the main use cases or sub processes involved in your system, right? You decompose this into these, and your external entities remain same. You do not add external entities, right? And you have to preserve there might be new data flows now between the processes. There might be few data stores visible now because you are inside the system, right? And something like this. But you have to still preserve the data flows in the context diagram. I mean, if this were A, B and C, you still have to have that A, B and C, right? There might be new now, right? There might be a lot of data flows now visible in and out of the data store, right? But you have to still preserve your original A, B and C. It's like zooming on the map. It's like zooming on the map. So you go from country to a state, but country borders are still intact. You do not introduce new external entities in the level 1 diagram, and you balance or you preserve your data flows from the context diagram in a level 1 diagram. Again, these bubbles, these are the sub processes for this main process. This should be ideally 7 plus or minus 2 max. Do not make it too complex. Do not keep it like. Then we go to next diagram. So this was your level 1 diagram, right? Now let's pick this. So let's say CC and DD. Let's pick this subsystem, sub 1, right? Now level 2 diagram is pick any subsystem in level 1 diagram and then start decomposing this. Start refining this. Right? So sub 1 has, now to balance the DFD, remember sub 1 has two incoming data flows, CC and BB, and 1 outgoing data flow, DD. And then there's flight. Now this is your level 2 diagram. You have zoomed in on any one sub process in the level 1 diagram. There are new data flow introduced. Maybe you can introduce new data stores, right? Those those were not visible in the level 1 diagram. External entities, if you show them, they have to be the same as they are present in level 0 and level 1. But even if you do not show them, that's okay. You can just show the incoming data flow, right? The main important thing is to balance the DFT. The data flows that were present for that subsystem in the level 1 diagram were BB in, CC in, DD out. So even if we decompose that sub-process into level of processes, number of processes, still you can see to this system, if you draw a boundary, BB and CC coming, DD go out. So we have preserved the data flows. Data stores could be sink or source in level 2 diagram. Here you can have a data store which only is receiving, for example this. This is a data store, looks like it's a black hole, right? It's only receiving the input flow, there's no output flow.
Right.
But it is allowed in level 2. Why?
Why so?
Because we are only focusing on one sub-process from level 1. So there are so many sub-processes in level 1, we are only focused on one. Might be there is some other sub-process which is reading the data from this. So bbarters.com is a social sharing website. Today we are going to draw a DFD for this software application, but we are not going to draw the entire, when you say level 0 diagram, how many processes will be there?
Just one.
Just one. Exactly. And that will be B2. We very fondly call it as B2, right? Then you have to identify, next thing is you have to identify
External entities.
external entities. All the external entities have to be identified. Now for bbarters.com, that is your social sharing app that we have created. Can you tell me what are the external entities?
Firstly, there is no hardware involved in it.
Yeah, we do not have sensors or CCTV camera providing us data, so no hardware. Good.
Then there are the users. Also admin, we ourselves administer the website.
So basically two human external entities. One is our users, dear God, all the users, right? And then there are admin, which are you and me and some people other, right? So admins and users are there. Apart from that, so we have covered hardware, we are done with humans, now we are left with
Software.
software. Are there any softwares which become external entities for B2?
Yeah, people can sign in through Facebook or Twitter, so they can be turned into software.
Yeah, yes, great, exactly, great point. In that scenario, it's safe to say that Facebook becomes the external entity for our app because Facebook uses data, that is the user info. It authenticates the user for us and it gives us the profile information, and then users can post data from bbarters.com onto the Facebook. So we provide data to the Facebook, that is content, shall we say. Admins take data like reports, right? Admin gets reports from our site, all the how many users in which month, from which country and all these things. And admins also give the data as in settings. So what about users? Users give the data, of course, the content. That's the most important thing. And what do they get back?
Content from other users.
Yeah, information, shall we say? Right. So this is pretty much our level 0 diagram, isn't it? So level 1, so I'm gonna take what UCC shall we take?
Blogging.
Okay, so first authentication.
Yeah.
Right. Okay. Then you could say,
Blogging.
okay, blog writing. Now, so our main B2 process in the level 0 diagram has been decomposed into these sub processes, right? Now what about external entities? Where does Facebook come into picture? I guess everywhere. We'll have to write one Facebook here, we'll have to write one Facebook here. What about user?
Similarly.
Again, we'll have to repeat user and suppose both sides. What about admin? Admin also we might have to repeat, right? Right, so what about data flow? Facebook we request Facebook the data for authentication, right? Once the user gives us their, what you would say, consent for using Facebook for login, we query Facebook for request. User gives the data to Facebook, username and password. Facebook returns the user info, right? Once authentication is done, then there is a status of authentication that user is authenticated to all the use cases. Authentication provides it to everyone. We basically say, we always check before giving any functionality whether the user has logged in or not. So that information goes everywhere. Now that we are told it, right? So it just goes here and here, the status, login status, whatever you could say. Alright, so then what about Facebook here? Blog reading can comment using Facebook comments, so it goes here. Again, blog readers could share that particular blog with others on Facebook, so that also goes. Alright, so I can show multiple flows from this to this. So I'll have to label it. So this is comments and this is share. Alright. Then what else? You could okay. What about user writing a blog? User will have to provide content. Correct?
Right.
That blog will be saved somewhere. So we'll have to draw a data store called as blog content. Right, that blog will be stored here. So blog entry is the label of input flow. Now when you say blog reading, that blog will be read from this data store. Safe to say?
Yeah.
So blog data, right? You say. We also have this simple normal sign up, right? User DB. We also, apart from Facebook sign in and Google and Twitter sign, we also have our normal sign up and sign in, right? I know it's not visible, but you hear me, right? Then authentication might check this information from request and it might provide the response also to the, right? Again, to give back the status to the other processes. Awesome. So, what about admin? Admin does what? Admin also has to authenticate, right? Authentication. Also, admin comes right now. Let's say we are not covered any use cases for admin because we are running out of space. And admin, what else? Admin will get reports. Okay. Admin can build blocks. Alright, so let's show this. Okay. Now, when it comes to chatting, user provides information to chatting. So let's provide information to chatting. Chat. That chatting is stored somewhere
Into database.
into a database. So I'll say where? I'll say chat DB and I'll say chatting info is stored here. Chatting not only stores data in a database, but chatting functionality also reads from it. You store the chat, you retrieve the chat, so both things are there. IFC transfer, how much IFCs need to be transferred, amount is given by user to IFC transfer, right? And IFC transfer, the amount is also stored in what you could say user info, because you have to update the IFCs of a user, so you have to again store them. For updating, for transferring IFCs, whatever amount user has asked, he has to first check whether that many IFCs are available in the user's account, so it also reads the current balance, right? And it stores the new balance, shall we say? Correct? Is there any process which is a miracle or black hole? Can you see it?
No.
Keep your eyes open.
Friends.
Friends is there, which is currently. Friends means user request to become a friend, right? So user gives the data of whose friend he wants to be, right? So data. Sometimes it's like request, friendship request. Sometimes it could be friendship approval. Correct?
Right.
Both data comes from user. That friendship data The combination of friends is also stored in somewhere. Let's say friends table, right? We also say this friends table is used by chatting. Only friends can chat, right? So friends, okay, so this is, it takes the data from this. So this is our level 1. If level 1 is this, then what about level 2? So let's try and take any one of this process and then decompose it further. Which one shall we take?
Blog writing.
Blog writing seems easy. Right. So now in order to balance the DFD, you have to just count the number of inflows, right? So there is this content, status, and which goes out? Blog entry. So two are incoming, status and content. One who's out is blog entry. Remember this? Okay. Blog writing, what are the use cases? Check, what do you say?
Authentication.
Or check, right? Check authentication. First thing, you cannot write a blog if you are not logged in. Then you could say write the blog, the actual process of writing the blog. So we have to give the interface and everything, right? And then last step would be saving the blog, correct?
The user supplying data.
Alright, so basically we can decompose our blog writing process into 3 sub-processes. Now check authentication means the authentication status will come, right? The auth status that will come from authentication use case. That auth check status will be provided for writing blog, right? Whether it's login or not. User entity will provide the content for writing the blog, correct? Then writing the blog, this information, the blog itself will be provided to saving blog process, which will save it to the database, or you could say store, blog table, safe to say, right? Is our DFD balanced? So you remember the 3 entries in the level 1 for blog writing?
Yeah.
Status, incoming,
Content.
from user incoming, outgoing was blog entry,
Yeah.
correct? So the DFD is balanced. All the data flows for blog writing that were present in level 1 diagram has been retained in the level 2 diagram, and then we have introduced some new internal data flows because we have expanded the use case, or you'd say process, correct?
Right.
So see here, this particular data store appears to be a sync, only incoming, not outgoing. Is it wrong?
Yeah, it's wrong.
It's not. I told you why. This is level 2. We're only focusing on blog writing. There might be another process called as blog reading, which might be retrieving from this, but we cannot show that because our focus is on writing. So that's the point. You can have a data store with only inputs or only outputs in level 2. So enjoy drawing your data flow diagrams for your college projects or your commercial project. They are very helpful. Thank you.